Okay, we're up to 4-3, day one. So the title, Simplifying Rational, another word for rational, remember, fractions, expressions. I'm going to hit that pretty hard. So here we go. This is an expression. Now, just so you know, that's different than an equation. You've learned a lot about equations over your years. For example, if I had like a plus 2 equals 10, that's balanced. The left-hand side equals the right-hand side. We know that's true, but if I divided everything by 2, I would get 4 plus 1 equals 5. So you can divide an equation by anything you want at any time. You can multiply any equation you want at any time. Let's say 2. We get 16 plus 4 equals 20. See, those are things, little tricks up your sleeve that you can use if it's an equation. If it's an expression, and I have something like this, 8 plus 2, and you were in first grade, it was like, what's the answer? You go, oh, that's 10. You would never think about multiplying this by 2, dividing this by 2. So get those thoughts out of your head. Multiplying by 2, dividing by 2, it's going to be different. These are expressions, but there are going to be tricks that you're going to use when dealing with an expression. So with that in mind, let me get rid of this. Number one, looks awfully simple, but you got to know your homework's not going to look like that. I'm just trying to develop a foundation so that you know what to do and what not to do. That's the whole point of this pre-lesson. So let's experiment. 8 plus 2 over 2. If I said, hey guys, try it, you guys would probably go 8 plus 2 is 10 over 2, and you go, hey, that's 5. Now, what if a different student went, hey, I see these 2's. I'm just going to cancel them out. Well, they would get 8, and you know that's not right. So why is this wrong? Well, we're going to talk about that in an example coming up. But when you have a situation like this, and this is somewhat similar to what you're going to be dealing with, you just have to know that you cannot cross out those x squareds. So this one would be simplified, okay? So I'm just going to leave that alone for now. Now, how about this one? Well, this one is simply this one flipped. Now, if I said, hey, what's the answer to this? I'd go 2 over 10, which is 1/5. There's no denying that. Now, I'm going to experiment here. This one, I'm going to experiment with this. I'm going to write it like this. 8 over 2 plus 2 over 2. We go, aha, that's 4 plus 1, that's 5. So that's an okay thing to do. Now, what if I applied that to this one? Well, if I split that up, I'd get 1/4. If I split that up, I'd get 2 over 2, which is 1. I'd get 1 1/4. So that's obviously wrong. So what am I saying? If you have one denominator, you can rewrite it like this. The denominator can go into all the things in the numerator, and that's okay. But if you have multi-denominators separated by addition, subtraction, do not split these up, okay? Just doesn't work. Now, here comes the point I really want you guys to understand. Notice I've got 2 times 6, 2 times 7. If I said, hey guys, try it, you would get 12 over 14, and 2 goes into that 6 times, 2 goes into that 7 times. There's my answer, 6/7. So what if a student in this situation went, wank, 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 wank? What would they be left with? 6/7. All right, well, how come over here I couldn't cancel the 2's? All of a sudden here I can. Here it comes. It'll be a little quirky, but that's me. The rule is factor, factor, hactor, hactor. Now, what does it mean to be a factor? Well, to factor 27, I would say 9 times 3. See how they're connected by multiplication? That's the key. Then they are factors. Then you can hack them. I'm going to say that about 10,000 times. So how do you know if they're factors? Well, if they're connected by multiplication. Now, let's go ahead to number 4, okay? This is more of your algebra thing. How is this binomial connected to that binomial? By multiplication. They've been factored. How is this binomial connected to that binomial? Multiplication. Guess what? Factor, 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 factor. These are multiplied together. These are multiplied together. So this problem is very similar to this problem. This has got numbers. This is algebra. But these two are very similar. So I go, aha, these are the same. So I can cancel them. And then I'd be left with x plus 3 all over x plus 7. Now, some of you are like, well, let's cancel those x's. Oh, no, you didn't. That's x plus 3, x plus 7. You're done. Think of it this way. You don't know what this number is. You don't know what this number is right now. You do know that these are the same. You don't know what the numbers are, but you know they're the same no matter what x is. So this one you'd be done. Now, if somebody left in parentheses, that'd be fine too. They're the same. Now, number 5. This is what your homework's going to look like. So you can see it's a lot more work compared to this. So let me get some space here. And I want you guys all to repeat after me. Factor, factor. Okay, good job. Hector, hector. I heard you. All right, now listen. The key to this is a MAPASAP. You want to factor as much as possible, as soon as possible. If you keep that golden rule alive during this section, you'll be way better off. So I look at the top and I say, hey, I want to take out as much as possible as soon as possible. Don't worry about the bottom. Notice this has an x, 2 x's, 3 x's. I can take an x out of that. Now this begins the process of factoring, but I haven't completely factored this, because look at what this gives me, a trinomial. So I'm going to get x, I'm going to factor the trinomial into 2 binomials. So it'll be x minus 8, x plus 3. So there's the numerator completely factored. Now the denominator, I look at that and I think, okay, take out as much as possible as soon as possible. So again, I can take an x out. I'm left with x squared plus x minus 72. That is a trinomial, so I'm going to bring this down into the denominator. I know a trinomial factors into 2 binomials, so that's x. What are 2 factors of negative 72 that add up to 1? Well, I'm seeing a 9 and an 8 coming. Which one's got to be negative? The smaller one. The bigger one needs to be positive. So, remember, factor, factor, and it's like, then I can hector, hector. But there's a twist. They are going to ask you a lot, find the domain. Now, remember domain on expressions or functions? We always, here's my little clue, D stands for denominator only. So I look down here and I go, aha, I can't have a 0. This is a big no-no. So what value for x would cause that whole denominator to be 0 in that spot? 0. So x can't equal 0. Now we're not going to graph these, no asymptotes. Kind of done with that for a bit. How about this one? Negative 9. How about this one? 8. So here's your domain of this expression, but you can't tell what the domain is from here. You have to factor it first, and then it can jump out at you. So keep that in mind. But we're not done yet, because the instructions say simplify. So now look at factor, factor, hector, hector. So now these x's are the same, and they're connected to these stuff by multiplication. These x minus 8s are exactly the same, and they're connected by multiplication. X plus 3 is not the same as x plus 9, so you are done. Yes, you're going to be tempted to cancel these x's, but that's a big no-no. So this is it. You simplified it, and you found the domain. One more problem in the pre-lesson. Okay, just so you can wrap your brain around the difference between an equation and an expression, notice this is equals 0, and it's going to say solve. You've done these. I'm not going to finish this problem. But on this problem, you could just say, hey, I don't want to plug this in for A, B, C, if I put that all into quadratic formula. You can, but save some time. You can divide that all by 2. You get x squared plus 4x plus 5 equals 0. When you plug this stuff into the quadratic formula, you're going to get an answer. Or if you factor, you're going to get an answer. Now, if I didn't divide by 2, and I plugged all this into the quadratic formula, I'm going to get the same thing as I get here. This is just going to be more work. So a lot of students, if you divide by 2, students are like, well, when I get this answer, do I have to multiply my answer by 2? No, no, no. They're the exact same thing. They just look different. My point is, if it's an equation and you're trying to solve it, you can divide just to reduce numbers. But this one, a lot of students are like, oh, that's the same thing. No, it isn't. So think, and I said this earlier, but if you're on, elementary school, 2 plus 8, that's an expression. If you were to simplify this, you'd go, oh, that's 10. Yep, you found the answer. Now you can't add this to this to this. So it's like, how am I supposed to simplify this then? This is where, in this case, simplify really means factor completely, okay? I'm like, oh, I can take a 2 out. That'd be x squared plus 4x plus 5, and this would be, well, I would try to factor this, x, like, nope, 5 and 1, I can't, it's just not going to happen. So this is completely factored, therefore it's considered simplified. So keep these separate. We're going to be doing this, not this. So don't think about dividing things by 2 off the bat, or multiplying the original, I would never multiply that by something to get started, so careful with that. All right, check out some sample problems on the next video. It will make more sense, I promise.